let's review the chain rule. And when we see a function like this, we don't want to make this mistake where we just do the derivative of cosine and then the derivative of sine and then the derivative of 2x. So this is not the derivative. We need to use the chain rule when there is an inside function and an outside function. And that's called a composite function. So the chain rule for this is the derivative of the outside, leaving the inside the same, times the derivative of the inside. And we can, these get more complicated when we have several, we have to do the chain rule several times. So let's start with some easier problems. So we'll find the derivative of that. We have the outside being the radical, and the inside is 5 minus 3x. It's easier if we write it as a fractional exponent. So now we do the derivative of the outside, leaving the inside the same, times the derivative of the inside. The derivative of 5 is 0, and the derivative of negative 3x is negative 3. So now we have negative 3 over 2 radical 5 minus 3x. Because we have a negative exponent, so we put that in the denominator. And pause the video and try that one. Derivative of the outside, leaving the inside the same, times the derivative of the inside. The derivative of x squared is 2x. The derivative of negative 2x is negative 2. And the derivative of 1 is 0. So we can write this as 2x minus 2 in the numerator, 2 in the denominator, then a radical in the denominator. And the 2's can cancel, so we'll have x minus 1. All right, and this one just has a little extra algebra that we can do. This is x minus 1 squared square root, and when we have a square root of a square, we can write it as x minus 1 with an absolute value, and this turns out to be positive or negative 1. All right, if we have rationals, we could do the quotient rule on the inside, but if we rewrite it, we can do that and then have a 1/2 for the radical. So the rational, we had a negative 1 to do the reciprocal, and then we have a 1/2. So before we do the chain rule, let's rewrite it. So instead of requiring a quotient rule and a chain rule, now we just have one chain rule. The derivative of the outside, we multiply by -1/2, and we have -1/2 minus 1, leaving the inside the same, times the derivative of the inside. And the 2's will cancel. We have a negative, so we can write it as -t over square root Okay, let's go to pause the video and try that one. Let's rewrite it with a negative exponent so that we don't have to do a quotient rule. Now we can just do the chain rule. Multiply by the exponent, leaving the inside the same, times the derivative of the inside. We have to be careful about where these exponents are. So this exponent is on the x. If the 2 were right there, that would be the secant is squared. So we'll see more of those after this. To identify the inside and the outside, think about where the parentheses would go. And here the square goes inside the parentheses. So we have the outside and the inside. The derivative of the outside, secant tangent, but we have to copy the x squared on both of them, because that's leaving the inside the same, times the derivative of the inside. All right, try that one. Pause the video. So if we put parentheses in, it would look like that. And pi is just a number, so we don't need a product rule. It's not two different variables. And we'll do the derivative using the chain rule. The derivative of the outside, leaving the inside the same, times the derivative of the inside is just pi. Now, we have to remember that that 2 means this. So if we write it with parentheses, it's easier to see and easier to remember what is inside and what is outside. So now we do the derivative of the outside, leaving the inside the same, times the derivative of the inside. right, pause the video and try that one. Remember that that exponent would be there, so now we see the inside and the outside. The derivative is the derivative of the outside, leaving the inside the same, times the derivative of the inside. And that's going to be negative cosecant cotangent. So we can rewrite that as negative 3 cosecant cubed cotangent. So now we have to be careful of where the inside is, and we'll need to put a couple sets of parentheses on this one. So we know that it's cosine of pi t, and then the 2 is the exponent outside of everything. So now we have the outside is here, then there's another outside, and then the inside. So we'll do the chain rule twice. Here's the outside. We have to do the derivative of the outside. 2 times 5, 2 minus 1, leaving the inside the same. Now we multiply by the derivative of the inside. Well, that's composite, so we have another outside and an inside. So we're going to do the derivative of the outside, leaving the inside the same, and then the derivative of the inside. So we have negative 10 pi cosine pi t sine pi t Pause the video and try that one. We can see that that 2 is the outside. So we do the derivative of the outside, leaving the inside the same, times the derivative of the inside. But this cotangent will give us negative cosecant squared. The derivative of cotangent is negative cosecant squared, leaving the inside the same, and then times the derivative of the inside, which is pi. Negative for pi, cotangent cosecant squared, cotangent and find the equation of the tangent line. So that's where we have to find the slope and then do the point slope formula. The slope is the derivative. So we'll just make this our last example. So that means go ahead and do this one on your own. Pause the video. We have a product, so that means we can we have to do the product rule. The derivative will be that, and we'll have the first times the derivative of the second factor. We have the first factor and the second factor, and this is going to be 1/2 x squared plus 5 times the derivative of that, which is 2x. So that's 1/2 x squared plus 5 times 2x. So we had the first times the derivative of the second plus the second times the derivative of the first. Multiplying that, we have 2, we'll cancel that 2, we have x squared over 3x squared plus 5. Oops, forgot something. That's a negative 1/2. Negative 1/2. So we have square root. And here we have and so I was going a little fast. I forgot about that square root. That's a power of 1/2. So we multiply by half, but then we also have to subtract 1 from the 1/2. So it's a negative 1/2 there. That means this is a radical in the denominator. Instead of combining that, we'll just substitute a 2. And then with point slope, we'll have y minus y equals m, x minus x. This is 18 over 9, so I'll add 18 over 9. And we'll get that. And we'll stop there.